One of Introduction to Vectors. I would recommend that you download from the website this lesson notes to save you some time in writing. I have more than enough things for us to work through, and I'll kind of just guide through what I would like you to write down and then just kind of watch and listen on the rest. So here are some of our objectives on this first slide. What we're going to do first is talk about what is a vector. A vector is a directed line segment that has a magnitude. So I would like you to write down magnitude. When you hear that word, it is the length of the vector, how long the vector is. The other thing I want you to write down is the direction. It is the angle made with the positive x-axis. So here are some examples of vectors here. There's 4 of them. There's 1, 2, 3, and 4. So 4 different looking vectors. We're going to get more in depth with those. All right, next slide. The pieces to your vector. The first part is the initial point. Some textbooks call this the tail. And then the terminal point, the head. So here's an example here of a vector. It has an initial point P, and it goes off to Q, terminal P. So how you write that is P, Q with a line, and that line has an arrow heading off to show the direction that it's going to Q. So go ahead and write that example down and those terms, initial point and terminal point. All right, the next thing of the parts of a vector, there's going to be an x component and a y component. So imagine this black vector, and we want to identify what is the distance on the x-axis. So we would count the boxes 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we would count the y-axis values 1, 2, 3, 4, 5, 6. Okay? When writing vectors in a component form, we use pointy brackets. So here's my pointy bracket with the x component and the y component. So if I wanted to write this vector here in the black, what that component form would look like is 9, 6. This is again component form. So it's not a bad idea to write this example down in your notes. Here is my vector, and I have to find the distance on the x-axis and the distance on the y-axis. And you will have to pay attention to positive and negative signs too. Alrighty. So this I took from a textbook. I liked it. It has lots of extra things here we don't really need. I just kind of put it more in paragraph form. We talked about the magnitude and the direction. And these are working more when we talk about with the force and velocity. So you probably have been introduced possibly in one of your science courses with vectors. So we talked about that vector PQ has the initial and terminal. We did this example here. What we're going to talk about next is its magnitude or length. This is the notation for the length of a vector. And we're going to use the distance formula. All right, then the last thing I want you to write down is a vector being a plane can be written as V equals PQ with an arrow, and it's denoted by a lowercase letter. So you'll see a lot of times letters with U, V's, and W's. Those will be your vectors. So you won't see this all the time, the P going off to Q. All right, so here's an example. I would recommend that you write this example down. You'll have some like these in your homework. So what we have is an xy plane with 2 vectors. I'm just going to color code this first vector This first vector is r going off to s, and the vector is v. And it has your ordered pairs 1, 2, and 4, 4. Then we have another vector starting at initial point P, heading off to Q, and it has a vector, we call that U, with the order pairs 0, 0, and 3, 2. And we want to figure out, are these two vectors equal to each other? Are they equivalent? And that's what we want to show. So again, you should be writing down this picture and working through it. All right. So in order for these two vectors to be equal, we must show they have the same length and the same direction, which is slope. So let's work through this solution. I'll kind of talk through it and tell you what to write down. So if you remember the distance formula equals the square root of the quantity of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 all squared. So what we do first is we're going to go ahead and find the distance in this red. So we're going to use our distance formula, and we get the square root of 13. And you've done the distance formula already in your previous classes. Then we're going to find the distance for r to s. So that length of the vector b. And we get square root of 13. So far we've shown that they have the same magnitude, the same length. Now let's check their slopes. For you to have the same slope, remember slope represents rise over run, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We won't spend the time going through that, but if you wanted to check on your own these two slopes, they both are the slope of 2/3. So you can go ahead and write this down along with its slope. They have the same magnitude and direction, so these two vectors are equal.